Welcome to Infini Models. I'm Jason, your host, and I do models. We're going to take a look at a couple things I just got in. It's kind of like a mailbag, but I'm not actually opening it. This is an LED tester. You can actually get a 2-pack of these for about $7 on Amazon. It's a little LED tester. I'll show you the inside of it here. It takes a 9-volt battery, and then it has a button down here and an LED. And then it has some circuitry with some headers on it. Let me show you how it works, and then we'll take a look at that board and see what we have. So I'm going to get a red and a blue LED here. And then what you can do with this is you can test it at different milliamp ranges. So I can plug this red one in, plus is at the top at 2 milliamps, and you really see, I mean, it lights at 2 milliamps. Let's do at 3, I guess that would be 4. Let's do 5. Lights at 5. And then let's do 20. It's a lot brighter. And then we can do the max is 30 milliamps. It's the max you want to put through an LED. This looks like, I don't know what ACA and CAC is. I'm not sure how that works. So I'm not gonna, it didn't come with any instructions, so I'm gonna look up how that works. But it looks like this one and this one are 2 milliamps. This one, and this one is 5 milliamps. So then you have 10, 20, 30. So we could, I don't know how many you can plug in here. Plug 2 at 20, 1 at 2 at 20, and we'll do 1 at 10. Yeah, it lights them all. So just to test LEDs, I got a project here a while back, and basically I will show you real quick. I got this kit. You do it yourself. You solder it up and turn it on, and then you press the start button, and it counts down. But as you can see, it stops counting down and then it picks back up. LEDs were bad. I didn't test each individual LED because there's 62 of them. So I will now test my LEDs before I put them in a board on my LED tester. So that is that. Just a little project I'm going to make and give out for gifts. So I got that, and then I also have a clock kit. This is supposedly a talking clock kit. I'll put these together and give them away as Christmas presents, just for family, friends. And then I also have this is supposedly a calculator. This would be pretty interesting, a little calculator chip. I got some other kits coming. Another thing I got is these make your own multimeter banana plug things. These are nice. I've already put some of these together. This is what they look like. They're stacking, and they actually have a good solder connection. I have another, I've gotten another type before that is a lot crappier made. Unfortunately, they won't plug into my power supply or my load without an adapter on it, but I do have some adapters, so they are pretty nice. And I just put a 5mm jack on there. I'm going to make one with a jack that goes the other way. That's the female end, but this is the male end, you know, just for testing purposes and things like that. You never know when I need to do that. So I had a need, and I ended up getting it. And then today I was using this transistor tester. I had this for a while, but it comes in pretty handy. You know, you can even test an LED in it, which I found out after I got the LED tester. but this takes a little longer. It takes longer to turn on. But I had the need to test and see, and then it blinked the LED, and now it's going to tell me it's a diode. See, it's a diode. It tells me what side's the cathode and what side's the anode. So it even tells me the forward voltage, and it has a capacitance. But where this comes in handy, and this came an issue earlier today in another video that was an epic fail that I will still let you guys see. When you test transistors, I have two different NPN transistors here, and splay the legs on these a little bit. So this is a 222, and I know that on this one, this is the collector base emitter. So if I plug this in, and I test it, takes a second. And it's, it tells me, emitter base collector, tells me the HFE, and then the forward voltage is 633 millivolts. So that tells me it's a BJT and PN transistor. And this is the 2N2222 2N42s. So then I have this other transistor here that I was like, I want to try this out. It's a BC547. I didn't want to look up the data sheet, so I plugged it into my transistor, and I was under the impression that it went, emitter base collector again, but the transistor told me I was wrong. And I think it's smarter than I am. This says it's collector base emitter, and it's a BJT NPN. It's about the same forward voltage. So, it's good with transistors. Sometimes the collector and the base are mixed up on it, so it comes in handy for that. So let's take a look at this LED tester and see what that board looks like. We don't take things apart unless I gotta fix it, but I just want to see what this board looks like here. Okay, so it's just single-sided. It's got three sets of female headers on it, 2 wires coming from the 9-volt supply. And let's see if I can zoom in on this and get you a closer look at the board here. Yeah, there we go. So we just basically have a bunch of different resistors dropping different things. What is that? 241, 241. So basically all the different resistors going across there. I'm not going to cross-reference all the resistors. Looks like we have a 0 ohm link. So it's basically just a resistive dropper, kind of just dropping the 9 volts down to the correct milliamperage that you need. So maybe in another video I will test it for accuracy. There we go. But yeah, it takes a 9-volt battery. The 9-volt battery is a pretty snug fit. I'll show you that right now. Let's zoom out here. Tone that down a little bit. So I'll put the battery in and I'll show you. It's just an Amazon Basics battery. As you can see, it is a snug fit. I mean, it is a snug fit. So, and then, it goes together, but that battery is packed in there. So, normally I use rechargeable nickel metal hydride batteries, interloopers, but I didn't have any more of the 9 volts. I have to get some more, so okay, that one doesn't want to go in for some reason, or the wire's stuck under it. The board's a little off there. Yeah, they really make this a certain kind of fit, don't they? Drive those screws in there. I just took off the back of my screwdriver trying to do this. These are nice little screwdrivers. They store the little bits inside. I don't know if I've talked about these before, but it comes with, you know, all these bits, and then you just change it, and then you store what you need in the back there. And it's a nice little screwdriver. These are dirt cheap, a couple dollars on Amazon, or even cheaper on eBay. That's gonna do it for this video, guys. Oh, I got the servo shield for my clone of my Mojo V3, so I'm anxious to see how many servos I can drive from that FPGA board. How much power it can put out. I'm assuming that there is a power tap from the board on here. It's hard to see with the traces. The traces are all in black, but I'm curious to see where the power pins are, and I wonder if they're tapping right into the 5 volts. Because I know that it doesn't quite run on, the chip itself doesn't run on 5 volts, so I'm curious to see if you have to install external power or whatnot. Like this module over, yeah, so I'm not sure how that works. Look at it, it's hard to see how the traces are going to go. The board's going to sit on there like that. And you can see what pins they're going to. From the look of it, the top pin is your control pin, and the bottom 2 pins, one of them is power and one of them is ground. But I don't see a separate trace going to a specific point. All these traces are going to get power, and for the chips, but I'm not seeing where power and ground is coming from on the actual servo pins. But there is a not a lot of information on these Mojo V3 boards. They're discontinued by their maker, what was Embedded Micro, and you know, it's hard to find some information, but I'm getting there. I'm getting some stuff worked out on it. So that's gonna do it for this video, guys. Thank you so much for watching.